Hello, season's greetings. This is Yarrow Stanchak with video 20.2, the first public demonstration of the 6-pole, 3-coil, zero-force motor, a low-speed variant of the standard 4-pole, 2-coil arrangement. We finally achieved a reasonable state of tune with the help, of course, of a couple of laid-off elves, skilled in the art, no doubt, and we are at a point where we can show and put this motor through its paces. We're going to be demonstrating 24 to 60 volt operation under load. So here we go. I think you know all the components that are involved in it, and I won't elaborate on that. We'll give it a start here. Zero load, starting off at 24 volts. Okay, right now it's ramped up to a little bit over 2,000 RPM, 2030, 2025, no load. What we're going to do now is put the maximum load of my torque testing device on to see if we can stall this puppy. Okay, we've seen it slow down. That's a 770 gram load that we put onto it, and I think I'll zoom in a bit more on the screen and the power supply. It'll be relevant. Okay, so now we see that under 700 grams of load, it's at 0.56 amps. Screen display is pretty decent. In actuality, when you're looking at it, it's running at about a little bit over 12 watts, maybe 14 watts. Nice. Let's see what happens when we crank this up to 36 volts. So we have the same load. The pattern on the screen has improved, bigger spikes, etc. And we are at 0.65 amps at 36 volts. The RPM here, you'll have to trust me on this, is, you'll take my word for it, 2360 RPM. So, no issue here. Let's do the next step and push it up to 48. Well, still cranking along here. We'll stabilize the screen at the next voltage. Still the same load. The RPM now, at this point, with 48 volts, 3,064. So we've had a fairly steady increase as we jack up the voltage here. Very important. So let's do the acid test and push it to the limit of the power supply. Well, that's the limit here, and we're at 60 volts now, 0.79, 0.78. The screen display is a little bit funkier. Let's see if we can freeze it momentarily. And we'll zoom in on this just to give you a better look. So it's still frozen, and you can see and observe the amperage right here, and you can see the ring after the motor is shut down, powers up again, shuts down. You get that ring all the way across the board. Very interesting. And it looks like that may be salvageable and usable. So progressing a little bit further here, I'm going to shut this down to show you what the back EMF looks like. Bear with me. So now you have a sense of what the back EMF is and where it peaks. This is the internally generated power by the neos passing through the coils themselves. So what we've done to date here, to now, is we've shown you this entire demonstration. We've shown that this motor can be progressively pushed all the way up to 60 volts, tremendous flexibility, and we're not even tapping the voltage, at 60 volts, we're not even tapping the maximum torque that this machine will produce. Overall, before I close out, I do want to point out that this state of tune is at 45% efficiency pretty much across the board from 24 volts up to 60 volts. So there's more to come with this. This is extremely interesting, and look forward to doing another demonstration video in the near future when we have something positive to show again. Thank you for watching. Happy New Year.